Right, well, good morning, and welcome on the second day of DevDays again. And we'll be looking at IHE XDS, combining the best of IHE XDS, the architectural principles, with some features of FHIR. Some of this is actually a bit speculative as to where can we actually take this. Given our base ingredients, what sort of soup or dish can we create that tastes the most delicious way? Okay, hence the reference to the Swedish chief, and although he's cooking a vegetarian meal, I'd rather be the chief than actually the pumpkin in this particular case. But that as an aside. So, the agenda for this morning, for this session is, yes, let's look at the strength of XDS. And I will very briefly assume that you've never heard of XDS, so I will a very brief introduction as to the best features of XDS. But then we start looking at, well, XDS on FHIR, what does that look like? And IHE already has created some specifications in that area. Then we look at FHIR documents, because those are things you can exchange using XDS. Then about taking elements out of documents, processing document content. What is a document actually in terms of XDS? What is a document? And that's actually a rather strange discussion to have, because it's a lot more than what you would think. And then we look at on-demand documents, which is one of the very powerful features of XDS and combines very well with document principles that we have in the FHIR standard. So it's sort of nice if you already know about XDS, but it's not real prerequisite here. So let's first focus on the strength of XDS. If we are going to combine those with FHIR, we first need to know what they are. Well, most of you will know what XDS is, and in case you don't, it's an architectural or workflow principle where we separate the management of metadata from the archival of the actual documents. Because, basic principle of XDS, we have some author that archives the document and the document metadata and sends both to a document repository archives the document, forwards the metadata to a centralized registry. That could be, for example, one at the national level or one at the regional level. Then you query the metadata. Are there any discharge letters for patient Smith in the last 6 months? And then based on the metadata, yeah, there is such a document in hospital number 5. And then you basically go to the archive in hospital 5 and retrieve the document. So that, in a nutshell, is XDS. Just the separation of the management of the metadata and the actual archival of the documents. Okay? Now, if you then look at metadata, because the strength of XDS lies in the metadata. The better your metadata, the more quality your metadata has, the richer it is, the richer the set of use cases you can actually satisfy with such an IHE XDS environment. If your metadata is very thin and it's purely populated, garbage in is garbage out, then you won't be able to satisfy a lot of workflow scenarios when you're, for example, querying for documents. Now, if you look at Wikipedia, and Wikipedia is a most generic definition of metadata, it says, metadata is data about data. You're kind of, okay, yeah, that's terribly useful, right? Well, actually, what they then list here is, well, means of creation. What's the purpose of the data? When was it created? Who created this? And where can this document be found, or this thing, this data? What are the standards used? Please note, this is obviously a definition that's totally irrespective from healthcare or whatever. And these are certainly things we want to know about when we talk about clinical documents. Actually, IHE has given a lot of thought to this metadata definition. So they created a list of a lot of metadata items, you see them here, and they have different purposes. They all serve a different purpose. So some, yes, help to identify who's the patient that this document is about. Where did this document come from? Who authored it? What organization? What person? Some privacy security oriented metadata elements. Elements related to the life cycle of a document. All documents have a life cycle. They are created, they have an active phase, and then they are deprecated when they have reached their end of their usefulness, For example, laboratory results, typically after 10 years, there is no real value to them anymore, mostly. Okay. Or a document could have been replaced by a new version of the document. But anyway, that's document lifecycle metadata. Exchange-related metadata and descriptive metadata, and that's where you will find, for example, details of the clinical side of things. The surgical procedure that this document documents, or the kind of image or the image modality if we have taken an image, which is also a document in the sense of IHE XDS. So it's a fairly rich set of metadata, which is harmonized between document management system vendors, archives essentially, and the requirements that you have for exchange, for querying of such documents. Now, what is a document? Well, in XDS, it is assumed that the author of the document determines what a document is. That sounds a bit strange, but it's the author of the document that decides at some point in time, when it's relevant to them, patient has been discharged, image has been created, whenever, now I'm going to create this document thing and I'm going to archive it. And I'm going to take, as an author, clinical responsibility for the content of the document. And you go like, well, yeah, of course. Well, later on in the presentation, I will show you that there are some documents where this is not true anymore, and then you have to question, well, is there still a document in the clinical sense? You may be familiar with this model, the refined European interoperability framework, to give you the full term for it. It's a multi-layer model that effectively aims to show you that if you want to achieve interoperability, you have to achieve interoperability and agreement at all of these levels of abstraction. It's not enough to just have agreement on the technical level. Okay? You also have to have agreement on the legal level. If I'm going to exchange between my country and your country, but there is some legal requirement that doesn't actually allow us to do so, well, then we can talk about the technical aspect until we're blue in the face, but it's not going to happen, right? So you need to have this interoperability agreements at the organizational level, at the workflow level, at the requirements or information model level. You need to have it at all of those levels. Why am I showing you that? Well, IHE has a different term for it, and it's called an affinity domain. IHE says, well, once you have agreement on all of this, which is a fair bucket of stuff, actually, oh, then we have this nice technical standard that tells you how to exchange documents. Okay, that's like sweeping a lot of problems under the carpet, because this is all of those layers we saw on the previous diagram that are not related to the technical aspect that you can easily standardize. Okay? So we see in affinity domain a group of organizations or systems that has shared policies, and typically in affinity domain, healthcare region, typically when we look at current XDS deployment, they will have to define all sorts of things to document their own affinity domain rules, the policies, the applicable legislation, etc. Now, XDS out of the box, as it was defined in 2005, is not based on FHIR. Okay? Because FHIR obviously wasn't even there at that point in time. So if you look at XDS, formerly known as XDS.B, the second version of XDS, is based on web services. And the web services stack, the actual metadata expression is based on an EBRIM standard. And you go like, EBRIM. Okay, have you ever heard of EBRIM? Okay, only if you knew about XDS, all right? It's actually part of the EBXML family of standards. If you still remember EBXML was supposed to be IBM's competitor for web services, which was more a Microsoft type of thing. Now, EBXML, we still see a bit of that in banking, but other than that, it's totally gone. Okay? But it's the metadata format we're using, very rich XML, complex XML structure to express the metadata. And this is fine, this version of XDS, for resource-rich applications. If you have a big server sitting somewhere, and it's a back-end type of communication, then this is fine. But if there's one thing you don't want on a cell phone, for example, or in a lightweight app, it's the web services stack and heavyweight XML parsing. Okay, because your battery life will go down the drain pretty quickly if you do that. Okay, so if we're talking about XDS on FHIR, then we're talking about a FHIR version of XDS. Same principles, separation of metadata from the actual storage, but the technology layer has been swapped out, so to speak, to be about REST and FHIR, and a FHIR way of expressing the metadata. But the underlying architecture is still obviously one or more of the same. So this is the metadata expression that we have in MHD. MHD is Mobile Access to Health Documents. That's the new name for, let's say, the FHIR version of XDS. And jointly with IHE, HL7 has created this resource, document reference, to capture the exact same metadata that we already had in XDS.B. Years of experience with it, so obviously you want to support that in a standard like FHIR as well. Document title, document type. This is actually where the document itself lives, or where a reference to the document can be found. Here we have document relationships. I am a document and I replace some other document. And this is the clinical context. What's the surgical procedure that this document relates to, etc. Okay. Now this is a much simpler expression of the metadata than we had in the older XDS.B standard. So how does it look like from a FHIR perspective? Well, if you're going to submit a document and metadata, because it's always the tuple of the two, to an XDS environment, then it's going to be a bundle. Well, this is a FHIR conference, you know about bundles. So we have a bundle with multiple entries, and the entries in this case are mainly document reference, the metadata, and a binary resource that actually holds the document, the blob. And given that XDS doesn't actually specify what MIME type to use for a document, it could be PDF, it could be CDA, it could be a movie, it could be anything really, that's specified as part of the binary resource. So that's the general solution, document metadata and the actual binary. The response will be a transaction response bundle. So this transaction bundle basically posts 2 new resources to the server, and that gives us a response bundle that tells us whether that transaction was executed okay or not. Now, this audience is probably not terribly scared if I show you some XML. Okay, sometimes people are relatively scared by that, but you probably love it. So here we have the bundle of type transaction, where we have entries, and one of the entries is the document reference, the metadata part, but I'm not showing you the detail, and the other entry is the binary resource, in this case of MIME type text/XML, and here it's not referenced, but it's actually embedded, so we have an encoded version of the document. Just as an example of the post transaction. Now obviously one of the main use cases for doing this is to query for documents, because XDS is publish followed by pull, by a query mechanism. So the query mechanism, well, basically almost all of the metadata items you saw in the document reference resource can be queried. And you know what the query mechanism is in FHIR, so you can do stuff like give me all documents, or rather all document references, where the patient has a certain citizen identifier, for example. Or give me all document references for the patient with a certain citizen identifier, and those documents should be of type such and such, a discharge letter, I don't know what this type actually is, and documents created after the 1st of January 2019. So you can basically use the full query, the power of the query mechanism that FHIR has in order to query for document references, which means you have metadata sets, and in the metadata set you have a reference or embedded the actual document itself. Okay, so here we have an example of the response to such a query. And we're looking at give me all document references for the patient with a certain business identifier, a citizen identifier. We find 2 matching results, okay, and which means that here we have 2 entries in our response structure, a document reference, and the document reference tells us in this case what the unique identifier of the document is, that the document is of type BRAIN MRI, that the document was created at this point in time, 1st of March 2017, and that the document itself can be found at a certain URL. So I can go out to that URL that you see over there and basically do a get on that URL. It's a relative URL, and basically get hold of my binary here. And in this case, it's actually a DICOM COS object that contains references to my BRAIN MRI study my images. So we see the metadata here, and obviously the link, as I said, to the actual binary. Now, a nice feature of FHIR is that it also supports, and you may never have used this, the search for full text search. There are 2 predefined parameters, _text and _content, and those allow you both to do text searches. So you can actually do stuff like, well, give me all documents for this specific patient, and where the text contains the word bone or the word liver and the word metastasis. Hey, this is something we don't have out of the box in XDS.B, but it would certainly be a very nice feature to have. And FHIR supports this out of the box. Okay, it's not all servers that will support this by default, but FHIR already has support for it in the FHIR standards. It's up to the servers, obviously, to implement this. If you retrieve a document, well, it's a simple get. So mostly it will be the get for a certain binary, and that will return the binary as it was when you posted it. So that's a relatively trivial thing. So now we have a RESTful way to basically do XDS.B. But what if my document is an image? Diagnostic imaging. Now in DICOM, obviously, they've also seen the writing on the wall and lightweight applications and web apps and what do you know. So DICOM has been working on Daikon Web. And Daikon Web is a RESTful version of DICOM, which greatly eases the access basically to DICOM images. Okay, not all PACS archives, etc. support it nowadays, but we're speculating a bit as where this is heading, right? So there's a lot of interest in this. There are performance reasons for doing this, and this also have the nice feature that you can separate the metadata from the actual images, which is not in traditional DICOM, but this is one way of handling that relatively easily. So again, it sort of fits with the XDS way of thinking, metadata versus image separate from each other. Now, FHIR documents is the other part where you have overlap because, as you know, XDS is document agnostic. You can basically exchange any document type. And one of those document types could be a FHIR document. And yesterday I spoke at length about FHIR documents, so I'm not going to repeat that. But FHIR documents are focused on persistence, about human readability and authenticated content. Multiple resources, modeled as a bundle. In FHIR, this sort of thing is quite often a bundle of type document that contains text in sections, and the text may have been enriched with structured resources, and the data in the structured resources is meant for the software receivers of the document. Right? In general, FHIR documents have a structure which is a bundle of type document, okay, which contains composition. That's the metadata, effectively, of the document. Who's the author, what's the document type, when was this written, etc. Text sections with text, and the text may have been enriched with resources here for software receivers, structured data. And you can even send a style sheet if you want to manipulate how the receiver should display the FHIR document as a footnote. Now, IHE, given that we have documents, structured documents like this one, FHIR documents, and CDA documents, and those are also structured, but then based on HL7 version 3 models, you can sometimes extract some data from a document. And there are two profiles to do this, QED-M, which just means it's a FHIR-based profile, and MXDE. Those are two profiles that allow you to extract FHIR resources from a document. Okay, so you can say, well, of all of those documents for this patient that I have, extract the allergy stuff out of all of those documents. So I can just get a list of allergy information and ignore all the rest of detail that's in the documents. Okay, there are clinical safety issues with this if you're not careful, right? Because a document has a characteristic which is, I, as the author, I selected a particular bit of information and I created a particular context. And now you're taking one bit of information out of the context of that one single document. There are dangers associated with that. If you write a discharge letter for somebody broken their leg, you're not going to mention that they have an allergy to hives, because it's totally irrelevant in that context. Okay? So you've got to be very careful in doing that, taking information out of a document. And that's why IHE itself says, well, if you extract stuff out of a document, you have to preserve the link to where it came from, so that at least the user can then look at the full document if they want to. And the FHIR way of doing this would be to use the provenance resource. Where did this come from? Provenance. Okay, so extraction from documents, there are clinical safety issues around that. However, a lot of documents, whether those are CDA or FHIR documents, are fully automatically generated from a database. You just have your EHR, lots of structured data. You just automatically push a button, it generates a document. Actually, no human involvement whatsoever, which means there is no context. Okay, and that means it's safe to yank something out of that context. But be careful. What is a document? Another interesting question. So, for example, we have these very nice medical document principles. Okay, let's start with those. Yes, documents have the aim to be about persistence. So I once saw an XDS project where if the patient was moved from bed 1 to bed 2, they would create a document for it. And I went like, that's not something I want to persist until eternity. It's not really relevant long-term in a medical record, right? But anyway, documents persistence, stewardship, potential for authentication, and context and wholeness. And that's the part I just spoke about, that a document has a self-contained story. It has its own context, more or less. And human readability. So if you look at this, then yeah, FHIR documents, they meet all of those criteria. But what is an XDS document in the context of, well, XDS? And if you ask around and the experts say like, well, it could be this and it could be that. And at the end of the day, the definition is, it's some sort of blob that has a MIME type. That's a very flexible definition. This includes all video and it includes all images, it includes whatever, right? But one of the other characteristics, not just has a blob with a MIME type, but it's authored by the source of the information. There is some source that uploaded the document that has ownership, authorship over the content of the document. I pointed this out before, but we'll get to that, why it's relevant. So, now we get to edge use cases. You know, in FHIR we have questionnaires. Very nice resource where you can display a questionnaire and you fill in the questionnaire and you create a questionnaire response. That's a filled-in questionnaire, effectively. Is that a document in the XDS sense of the definition? Well, yeah, it's authored by one resource. It's meant for persistence. Yeah, sure, I can see that. We have diagnostic report. Diagnostic report is, again, a FHIR resource that groups, but it's a dynamic grouper. It groups all sorts of observation resources. But it can change over time, this entire structure of diagnostic report with underlying observations. That's a bundle of resources, yes, but is it a document? Nah. If I take a snapshot of it, then maybe it's a document. In FHIR, we have the function of retrieving the current list. Give me the current list of allergy intolerances. That's always a very relevant question in clinical practice. What are the current allergies? What are the current medications? What are the current conditions that this patient has? Okay, so there is a way to support this. It's not to say all servers do this, but FHIR supports the handling of it. So then you return a bundle that contains all of the allergy intolerances for that particular patient. Is that bundle, which contains a list of active allergy intolerances, is that a document in the sense of XDS? Well, it's snapshot, it's the information I have at a particular point in time. So yeah, could be. We also have logical models. Remember, going back to our refined European interoperability framework, that we have models at this level. Those can be called requirement models or business models, okay, to define what is a blood pressure, irrespective of underlying technology. And then, for example, how to express a blood pressure in FHIR. Those are two different abstraction layers. And quite a lot of projects actually use these logical models or these information models that are more abstract than what you do at the FHIR resource and FHIR profiling level. So you may have, and the Netherlands, for example, has this, but some other countries have it as well, they have models called patient provider, but also medical history. Okay, well, that's not something we have in FHIR. Medication use, procedures, weight, tobacco use. Okay, well, that maps to actually multiple FHIR resources, because this is more conceptual or requirement-oriented. Okay, there are multiple standards that actually deal with defining these models. Now, you can actually use the FHIR tooling to express these requirement models. And there are actually projects that also do this. And then you can map these models to FHIR profiles. Because if you first define what is a blood pressure, and we all agree as to what a blood pressure is and what the components of a blood pressure are, then you can map it to FHIR profiles. Okay, you can agree upon it by all parties concerned, but then you instantiate it in a FHIR resources and you get a bundle of resources that claims I am a blood pressure according to this more abstract definition over there. But is that bundle, is that a document or not? Again, you end up in some bit of a edge use cases. Now, we have structure definition, as you know. Structure definition is the standard conformance resource used to document structures of individual resources. And graph definition, I'm going to talk about that tomorrow for 40 minutes, but graph definition is something that combines all of these fragments, these structure definitions, to jointly describe how an overall graph of FHIR resources should look like from a conformance perspective. So how should this document bundle look like, but also how should this resource bundle look like if we were using logical models. Then to go back to assembly versus authorship, and I talked about normally you have an author, somebody who takes responsibility over the clinical content, and they assemble, they create a document. But we also have a lot of use cases that people are working on now, that they have XDS type of environment, and then it's the client who gets to define how a server should assemble a document. I want you to create a document that lists the allergies and the medication, and then on the fly, you as a server have to assemble the document. Who is then the author of the document? Is that the server or is it the client? Because the client consciously chose to only look at certain aspects and ignore other aspects. Again, there are clinical safety issues around here, because if I say, well, create a document that creates this and such and so, but I forget about the allergies, and one of the allergies is very important, then it's my problem, because I ignored and I didn't ask for the allergies. Okay? So document authorship is one of the issues that we still have to talk about or discuss, because that fits with the on-demand document feature that XDS has. XDS has an on-demand option where you can create dynamic documents. Famous example is the medical summary. If you have some electronic healthcare record system out there, then, well, when should they create a medical summary document? They could, in principle, do this at any point in time. Okay? But you wanted to do sometimes, well, give me the latest and greatest, I want you to create a medical summary now. And that's this on-demand feature. Or, give me the current medication list, which is also an on-demand feature. Give me the list as of now, as a document. Okay? Now, to give you the equivalent and an example that's a bit more intuitive is, let's say I have a document metadata registry, and I have some party capable of creating a clock document. Well, as you can imagine, each and every time when you retrieve the clock document, you're going to retrieve a different document, because there's a different time in there. So you can register the metadata to state that I, as a server, have the capability to create a clock document, and the metadata will be in the metadata registry, just like normally in XDS. A client can then just query for, well, what documents do you have for Mr. Smith? Well, I have this clock document for Mr. Smith, and it's there. And then the consumer goes like, okay, I'm going to fetch the document. And then this party is going to go like, yeah, well, actually, I don't have it yet, so I'd better create it because it's an on-demand document. And then you construct the document with the current date and time, and you send it back to the querying party. And then you can choose to actually archive that document as well. So the use cases for this are the typical use case that I mentioned before, the medical summary or the current medication list. Those are the prime examples for using this on-demand feature. Now, a thing that fits very well with FHIR is that in FHIR a document is comprised of a composition, and the composition has references to all the underlying structured resources. Now, this is not a document yet. Okay, a FHIR document is a bundle of type document. It's a snapshot of this. This can still be changed in a RESTful way. You can still update this as you go along. But at some point in time, you can use the $document operation to actually create a snapshot of your current composition and all the resources contained therein, create a snapshot and create a FHIR document bundle, and that's what I'm going to archive. So this on-demand feature fits very well with this document operation that we have in the FHIR specification. So let's revisit this current. Remember, we had a feature in FHIR where you can use a current list to get hold of the current allergies, the current conditions, and the current medications. And that's, again, an operation on there. And each and every time when you use this, it's going to create a new latest and greatest list. So we have this snapshot behavior again. Okay? And that's, again, akin to the on-demand feature. So this fits with the on-demand feature of XDS again. We had our logical models, like blood pressure or some other smoking history or whatever. And again, each and every time when you go like, give me the FHIR resources that correspond with the tobacco use, then each and every time when I do that, I could potentially receive the latest and greatest version of it. On-demand feature. But it could be more wide-ranging like this one. Give me the latest instance of the cardiology dataset. Again, the on-demand feature in XDS. Relatively well fit. So let's look at the summary. So documents in XDS are a good option. And the on-demand feature, very powerful feature in XDS, has been added a couple of years ago. Is a very good fit with how FHIR has things like current list and the $document feature on composition. And, well, the whole RESTful stuff is obviously very fitting if you want lightweight implementations. But XDS in general is much more suited for the exchange of documents. The advantage if you use the FHIR way is obviously that you can have FHIR workflows next to XDS to deal with other workflows like order communication and stuff like that, because that's best not done in XDS. I always love it. I had a vendor in one of our training courses. I'm a trainer by profession, and so in our XDS training courses, and they were looking at this and they were going like, oh, wait a second. So you're telling me that for each and every transaction that we have in XDS.B, there is an equivalent FHIR thing in MHD? Yes. And they went like, okay, so why should I still implement this old XDS-B version? Because to them they were doing an own new implementation, and they went like, okay, I'm going to do this FHIR-full way of doing things, and then I'm going to build a gateway that if there's somebody out there that still wants to do the web services stuff, I will do a transformation back to the web services stuff. And that's exactly the other way around, as IHE currently still promotes the use of XDS and gateways to the FHIR space. But you could. Right. So that's the summary of this talk. Are there any questions? I just got a note for 5 minutes, so. Yes.
Maybe I missed it. So if you would have a FHIR-based document eventually, you store it in XDS and you retrieve it, would you get it as a binary then? Or would you get it as a other FHIR type back using the XDS mechanism?
Okay, so the question is on the storage of FHIR documents. Well, if you post a FHIR document, it would be stored as part of a binary. And one of the reasons, for example, is that if you create a digital signature for it, then you do that on the binary because you don't want to muck around with white space and that sort of stuff. So yes, if you retrieve it, the binary, then the binary will return the binary, the blob to you, but the MIME type will actually inform you that it's a FHIR document. So you will know how to basically deal with the binary and parse the content of the FHIR document.
The MIME type will be a document slash, what is it, XML plus FHIR or?
Application slash FHIR plus XML or FHIR plus JSON. Yes. Because in the metadata you already know it's a document. Yeah. Right? So that doesn't have to be in the MIME type itself. Yes.
As you know, there is a FHIR server that supports the conversion backwards to XDS already implemented.
So if I understand correctly, the question is, well, they already have XDS.B implemented, yes, and
kind of documents.
Is there a FHIR server that already supports out of the box a gateway more or less from yes, the FHIR world to the I know that some of the larger XDS vendors like well, 4Care and Tiani and stuff like that, they already support the MHD version out of the box. And I'm also aware that other vendors, and actually FHIRly is one of them, so the Fonk server there, well actually, officially I can't talk about that, but okay, we're working on a gateway also to support that as a facade, a FHIR facade for the XDS environment, which is a very natural obviously tool to use if you're working in that space, if you're slowly migrating or doing FHIR workflows next to XDS document archival. Those are two different use cases, so you have two different tool spaces for those. Yes, okay. Anything else? Yes?
To store the metadata for on-demand documents, do you recommend using the document reference FHIR resource? Because the problem is in document reference FHIR resource, it mandates the content and the attachment. Whereas in case of on-demand document, I may not have one when I'm creating the metadata.
Well, I don't think it's actually a problem. You could be right, I have never looked at it, or whether or not in the document reference we actually have a mandatory attachment. I would certainly hope not, because then we will have to have a look at it. So yes, the attachments is indeed mandatory. So what I have to ask my IHE colleagues to find out what their recommendation is. I actually haven't seen this in any discussion forum before. So we better have a look, but this is supposed to obviously to be supported. I'm sure there is a creative workaround at least, but no. We'll have to take this offline. There is an IHE channel if you want on the chat.fire.org, so I'll make sure to post the answer on that forum. Okay? One last question. There is 1 minute, so then we'll have to wrap up. Yes?
So, can you just tell the significance of document a manifest FHIR resource? Is it really necessary to use it?
Well, the manifest. Okay, so I very carefully skipped that. This is the concept of the submission set. If you know your classic XDS, then XDS you have to submit your documents in a batch. And the batch is only there to group documents when you post them. It's a bit like a bundle type of thing. Right, lights go out. It's time probably, I don't know. Anyway, so this document manifest contains the metadata of the submission. Because the party that authored the document may be a different one than the party that actually pushed these two documents to an XDS server. And the closest thing to me is provenance. So why this still needs to be an entirely full-blown, the whole role of this grouper, just like the submission set in XDS, has diminished over time. It used to have a much bigger role than it has today. So most implementations effectively ignore that part of the implementation. They do it in classic XDS, and they do it in FHIR. But officially it's still there because of this one-to-one mapping that you need to have between XDS and FHIR. So if it's important in your context, by all means use document manifest. But if it's not important, ignore it. It's up to you. In XDS, it used to be used as a grouping mechanism for documents. This radiology image and this radiology result are in one submission, and that's why they are associated with each other. But now we have a different way of doing that in XDS, so that's sort of slowly moving away. But it's an edge use case. But yes, my decision not to speak to it was a conscious decision. Yeah. But very good for pointing it out. So, time to wrap up. Thanks again. Feel free to discuss this further with me in the hallway, maybe, I don't know. And otherwise, enjoy any of the other subjects we're going to cover in the remaining of this conference. All right, thanks again.